Voskhod 2 and Alexei Leonov. On March 18, 1965, a Soviet cosmonaut named Alexei Leonov became the first human being in history to walk in space. He floated outside the Voskhod 2 spacecraft for 12 minutes while his crewmate, Pavel Belayev, remained inside. The Soviet government broadcast the event with enormous national pride. What they did not broadcast, and what was kept secret for decades, was what happened next. When Leonov tried to re-enter the spacecraft, his spacesuit had expanded in the vacuum of space. The suit was rigid with internal pressure and had ballooned outward to the point where his hands had pulled away from the gloves and his feet had pulled away from the boots. He could not bend his body enough to get back through the airlock. He was outside a spacecraft traveling at 17,000 miles per hour, unable to get back inside, with his oxygen supply running down. Leonov made a decision that was not in any mission protocol and that he did not tell ground control about until it was already done. He reached for the valve on his suit and manually bled pressure out of it, reducing the internal pressure below the minimum safety level. This made the suit flexible enough to move in, but also brought him dangerously close to the pressure threshold that causes nitrogen to bubble out of human blood, a condition called the bends that can be fatal. He bent, folded himself in head first, and pulled himself back into the airlock. He was drenched in sweat. He had lost over 6 pounds of body weight and fluid during those 12 minutes. The problems did not end there. During re-entry, the automatic guidance system failed, and the crew had to perform a manual re-entry, the first in Soviet spaceflight history. They landed 300 miles off course in the middle of the Ural forest in deep snow. Rescue teams could not reach them immediately. Leonov and Belyayev spent the night in the capsule in a frozen forest surrounded by wolves. They were recovered the following day. The Soviet Union announced the mission a complete success. The Mir fire. On February 23, 1997, 6 people were living aboard the Russian space station Mir when a routine procedure turned the station into something close to a death trap. A solid fuel oxygen canister, the type used to supplement the station's oxygen supply, was being activated by a crew member when it suddenly began burning. Not sparking, not overheating, burning with an open flame on a space station. Fire in space is not the same as fire on Earth. In microgravity, flames burn in a sphere rather than a cone, expanding outward in every direction simultaneously. There is no convection to pull hot gases upward and away. The fire burned for 90 seconds and reached temperatures of around 2,000 degrees Fahrenheit, throwing molten metal droplets across the module and filling the station with thick smoke. 3 of the 6 crew members were directly between the fire and the only available Soyuz escape capsule. If the fire had spread, they would have been trapped. The crew grabbed fire extinguishers and fought the blaze from multiple directions, while others pulled on oxygen masks. The station's smoke was so dense that visibility dropped to almost nothing inside the module. Crew members described not being able to see their hands in front of their faces. After 90 seconds, the canister burned itself out. The fire was over. The damage to the module was severe. Mir was already struggling with a long list of technical failures at that point in its life. Just 4 months later, in June 1997, an unmanned cargo ship collided with Mir during a manual docking test, puncturing one of the modules and causing a slow depressurization. The crew sealed off the damaged section and survived, but Mir was never fully the same again. 2 near catastrophes in the span of 4 months on a station that had been in orbit for over a decade. Gemini 8. On March 16, 1966, NASA astronauts Neil Armstrong and Dave Scott launched into orbit aboard Gemini 8 with a mission that had never been attempted before. They were going to perform the first docking of 2 spacecraft in history, linking up with an unmanned target vehicle called the Agena that was already in orbit. The docking went smoothly. Armstrong guided the capsule forward, and the 2 vehicles locked together cleanly. It was a historic moment. Then, almost immediately, both spacecraft started to roll. Armstrong assumed the problem was with the Agena, so he fired Gemini's own thrusters to counteract the movement. This made things dramatically worse. One of Gemini's own thrusters had become stuck in the open position and was firing continuously. By undocking from the Agena, Armstrong had just freed a wildly misfiring spacecraft with nothing to push against. The spin accelerated rapidly. Within minutes, Gemini 8 was rotating at 1 full revolution per second. 1 revolution per second is the threshold at which a human being begins to lose consciousness from the centrifugal force acting on the brain. Armstrong and Scott were approaching that threshold and accelerating toward it. Armstrong had only one option. He shut down the entire orbital maneuvering system and activated the re-entry control thrusters, a set of thrusters reserved exclusively for the final moments of descent back to Earth. This stopped the spin, but NASA's rules were absolute on this point. If the re-entry thrusters were fired for any reason other than re-entry, the mission was over immediately. The crew had to come home. Gemini 8 had been in orbit for less than 11 hours. Armstrong and Scott splashed down in the Pacific, far from the primary recovery zone, and had to wait 3 hours in rough seas for a rescue ship to arrive. Both men were severely nauseated from the spinning. Armstrong later described the final rotation rate as the point where vision was going. 3 years later, he walked on the moon. On this day, he came significantly closer to dying in orbit. Apollo 13. On April 11, 1970, NASA launched 3 astronauts toward the moon on what was supposed to be the third lunar landing in history. The crew was Jim Lovell, Jack Swigert, and Fred Hayes. After 2 successful moon landings, public interest in the Apollo program had dropped so significantly that the major television networks declined to broadcast the crew's live transmission from space 2 days into the mission. The astronauts joked about it. The mission felt routine. At 55 hours and 54 minutes into the flight, a mission controller in Houston asked the crew to perform a standard stir of the oxygen tanks in the service module, a routine procedure done to prevent the liquid oxygen from settling and giving inaccurate readings. Jack Swigert flipped the switch. Seconds later, the entire spacecraft shuddered. A loud bang echoed through the cabin. Every warning light on the panel lit up simultaneously. Jim Lovell looked out the window and saw something that made his stomach drop. A visible cloud of gas was venting out into space from the side of the spacecraft. He reported it to Houston with a phrase that became one of the most famous lines in the history of exploration. "Houston, we have a problem." One of the 2 liquid oxygen tanks in the service module had exploded. The explosion had damaged the second tank as well. Both were now venting their contents into space. The oxygen was not just for the astronauts to breathe, it was also the fuel source for the fuel cells that generated all of the spacecraft's electrical power. Within hours, the power was dying. The command module, the capsule they needed to survive re-entry back to Earth, was losing everything. Houston and the crew made the decision to abandon the command module entirely and move into the lunar module, the small, spider-shaped craft designed to land 2 men on the moon for a day and a half. It was now going to have to keep 3 men alive for 4 days, while the crippled spacecraft looped around the moon and crawled back to Earth. The lunar module had enough battery power for roughly 45 hours. The journey home would take 90. The carbon dioxide scrubbers designed to remove exhaled carbon dioxide from the air were not compatible between the 2 craft. The square filters from the command module could not fit into the round openings of the lunar module. Engineers on the ground had to design a makeshift adapter using nothing but materials the crew already had on board: cardboard, plastic bags, a sock, and duct tape. They read the instructions to the crew over the radio, and the astronauts built it by hand in orbit. It worked. The crew powered the command module down to the absolute minimum to preserve the batteries needed for re-entry, leaving the cabin so cold that condensation froze on the walls and the astronauts could see their own breath. They were so cold and so exhausted that none of them slept more than a few hours over 4 days. On April 17th, they re-entered the atmosphere and splashed down in the Pacific Ocean. All 3 men survived. The subsequent investigation found that the oxygen tank had been damaged during a routine ground test months earlier, and the fault had gone undetected. The most dangerous moment of the entire mission had been caused before the rocket ever left the ground.